is the reflective response for question number 19, which is talking about the probability of animals being eaten by wolves, which is quite pleasant, by the way. The first thing that I did was I made a tree diagram of all of the options. It told us that an animal had 1 in 20 chances of being sick, which means that the not sick animals were 19 out of 20. It told us that it had a 1 in 3 chance of being eaten if it was sick, which means if it was sick, it also had a 2/3 chance of not being eaten. And that if it was not sick, it had a 1 in 150 chance of being eaten, which means it would have a 149 over 150 chance of not being eaten. So I just went ahead and filled out the rest of the tree diagram, which comes in very helpful later on. And next we looked at the sample space, which is just the range of possibilities. Being sick and being eaten, being sick and being not eaten, being not sick but being eaten, and then being not sick and not eaten, which are the very lucky animals. But the question is specifically asking us not about whether the animal was sick, but whether it was eaten by wolves. So we're focusing on just the events that include being eaten by wolves, and that would be these last two, being sick and being not sick. So we come over here, and we follow out our chart to find the probability of an animal being both sick and eaten, and an animal being not sick and eaten. And the probability of being sick and eaten is 1 out of 60. The probability of being not sick and being eaten is 19 out of 3,000, which is significantly better odds. To get the probability of both the animals, because we're looking for an animal chosen at random, you would add the two together. So the probability of being eaten would be 1/60th times 19 over 3,000, which you add the fractions, it ends up being 69 out of 3,000, which simplifies to 23 out of 1,000. So your message this Valentine's Day is, congratulations, you only have 23 in 1,000 chances of being eaten by wolves. Happy mathing!